Today's lesson is on solving systems by elimination, and you're going to love this one because it is my favorite method because the math tends to be easier. So over here are all of your processes or procedures. So if you get stuck, you can always go back to this. But here's what you're going to do. You're going to first look at this system here. So here's an example of a system. You're going to check to see if a variable will cancel if you just add it together. So if you look at the system and add it together exactly as you have it, you haven't changed anything about it. If I add the x's down, I get 5 x's. But if I add the y's down, because they're opposite signs and the same number, if I add them, they actually cancel out. And that's what this means. Check to see if a variable will cancel. So that's the very first thing. I don't have to do anything to this system except for when I add it together, those y's are going to cancel. And you end up with 5x is equal to 40 because you got to add the 10 and the 30. So then really the second step here is just you would multiply one or both of the equations by something to get a variable to cancel out if you needed to. Since we don't have to here, we don't need to do anything with step 2. So that's why we went ahead to step 3 and we added the equations together. And now we are going to solve for this remaining variable, which is the x. So to solve for x, you're going to divide by 5. And you get x equals 8. So now I have half of my answer. And I'm going to then plug that answer, this answer right here, into one of the two original equations to find my y. It doesn't matter which one you plug it into. I'm either going to plug it into here, put 8 into here, or put 8 into here. These are smaller numbers. These are a little bit bigger numbers, but there's no negatives. So it's really half a dozen one way or another. So I'm going to choose the first equation, I guess, just because it's smaller numbers. So I'm going to take the 2x minus 3y. So instead of x, it's 3y equals 10. Then I'm going to take this value for x and I'm going to put it right in here. So to put the 8 right in there. So 2 times 8 is 16 minus 3y equals 10. Solve for y. So you're going to subtract 16 and you get negative 3y is equal to negative 6. Divide by negative 3. And then y will equal positive 2. So now I have both parts. So my solution is 8, 2. Now just to review another concept, since we're not graphing, if we have a solution, that means that the lines must be intersecting. So I know I have intersecting lines. And since I have a solution, these lines are consistent because consistent means they have a solution, whereas inconsistent means they don't have a solution. And then because I have one unique solution, it is independent. If I had more than one solution, they would be dependent. All right, let's look at another problem. So example 1, I'm going to make it really big so we can all see it. All right, so for example 1, trying to make it straight at the same time. Oh, there we go. Okay, so equation 1, if I add it exactly as you see it, the x's are going to cancel. So I want you to pause the video. You go ahead and solve for y, plug it back in and solve for x, and then restart the video. All right, so hopefully you're checking your answer now. So if I add the y's together, negative 5 and 6 gives me positive 1y. I want to put that in black, is equal to negative 1. So we've actually solved for y, and then all you need to do is take this value for y and plug it in here or here to find the value for x. So then the next step let's see. I think I'll sub into the first one. Again, it doesn't matter which one you sub into. You just need to choose one. So I've got 4x minus 5y. And instead of the y, I am going to replace it with -1. So this value here is going to go in here as a -1. So then do your math. I got 4x, -5 times -1 is +5 equals 33. Solve for x. I want to get rid of the 5, so I subtract 5. I get 4x equals 28. Divide by 4. And then your x is going to equal 7. So now I have both answers. You have to write them as an ordered pair, so I get 7, -1. So again, since I have one answer, I must have intersecting lines. Because I have a solution, the system is consistent. And because I have one unique solution, the system is independent. All right, let's make it a little tougher. All right, so in this example, I cannot just add them together and have the variables drop out. However, notice how these are the same coefficient, they're just not opposite signs. So you just need to multiply either this equation by -1 or this equation by -1 to manipulate it to make it the way you want it to. Doesn't matter which of these two equations you do, I'm going to multiply this one by -1. And so that means I'm distributing it all the way through. You're going to rewrite the entire system even if you didn't change an equation. So I didn't touch the first equation, so I have 2x plus 4y is equal to 6. For the second equation, a -1 multiplied through essentially changes all the signs. So I get a -x, a -4y, and don't forget a -2. So now when I add these together, the y's do cancel. Then 2x minus x is x. 6 minus 2 is 4. So we ended up getting a solution of x, which is 4. And you can plug that back in here or up here to solve for y. There's a lot less going on here, so I'm going to plug it into this one. So instead of x, I'm putting in 4. And then plus 4y equals 2. We're going to solve for y by subtracting the 4 from both sides. So I get 4y equals 2 minus 4 is -2. And so be careful when you divide by 4, you do not get 2 or -2. In fact, you get a fraction. Both 2 and 4 are divisible by 2, so you have to divide the top by 2 and the bottom by 2 to reduce that fraction. So you actually get -1 over 2. So your final answer is 4 1/2, not a decimal, a fraction. And again, I have a solution, so that means that I have intersecting lines. Because I have a solution, the system is consistent. And because I have a unique solution, it is independent. Okay? A couple more problems. All right, so this one, you've got some decisions to make, so you have to come up with a strategy. So I have to determine if I'm going to eliminate my x's or my y's. If I eliminate my x's, what do I make these both into? Since I can multiply 3 by 2 to get 6, I could eliminate the x's by multiplying this entire equation not just by 2, but by a -2. That way I would get a -6x here, which will cancel the 6x here. We have to have one's a negative and one's a positive. This one already has a plus minus, and I'm looking at 2 and 5. The only way to change them both into the same number would be to change them both into 10. So since this already has a negative, I don't need to multiply it by a negative, so I would just have to multiply this whole equation by 5 to make this a negative 10y. I would have to multiply this entire equation by 2 to make this a positive 10y so that they would cancel. Since it's more work to get rid of the y's, because I have to multiply 2 equations by something, than it is to get rid of the x's, I only have to multiply this equation. I'm going to get rid of the x's. So I'm going to multiply this entire equation by negative 2 so that I get a negative 6. And I'm going to multiply it all the way through. So negative 2 times 3x is negative 6x. Negative 2 times negative 2 times negative 2y is a positive 4y equals negative 2 times negative 4 is a positive 8. Bring down the second equation. You didn't touch it. Whoops, sorry about that. So now your x's cancel. You get 9y is equal to 45. When you divide by 9, you get y is equal to 5. So now I have one of my solutions, y. You can plug it in here or here to find your x. Even though these are bigger numbers, there are no negatives here, so I'm going to plug the 5 in up here. So 6x plus 5, instead of y, I'm putting parentheses. And so then this value is going to go here. So 6x plus 25 is equal to 37. We are solving for x, so subtract 25. And I get 6x is equal to 12. Divide by 6. And x is equal to 2. So our solution is 2, 5. So for the fourth time, we have one solution. So that means I have intersecting lines. Because I have one solution, they are consistent. And because I have a unique solution, the system is independent. All right, last one. So this one I want you to do on your own. I want you to pause the video, and I want you to before you pause the video, I want you to analyze whether you're going to get rid of your x's or your y's. What would you make this into? What would you make this into? So go ahead and pause the video, solve the system, and then come back to it. So if you were to get rid of the x's, you would make them both into 22, and one of them would have to be a negative. So you would multiply this whole equation by 11 or negative 11, and this whole equation by 2 or negative 2. We already have a plus minus going on here, and if you were to get rid of the y's, you'd want to make them into a 6. So I don't have to multiply by a negative because I already have a plus minus. So I would multiply this equation by 2 and this equation by 3. So I'm going to eliminate the y's because I don't have to multiply by a negative. So I'm going to multiply this entire equation by positive 2 and this entire equation by positive 3. I'm going to write what I have left over. And so don't forget to distribute this all the way through. So 2 times 2x is 4x. 2 times negative 3y is negative 6y. And 2 times 20 is 40. Then we are distributing this all the way through. So 3 times 11 is 33x. 3 times 2 is positive 6y. And 3 times negative 1 is negative 3. So now when I add, the y terms cancel. 34 and 33 is 37x equals 40 minus 3 is 37. So when you divide by 37, you get x is equal to 1. So now I have half my solution. You're going to plug it into either this x or this x. And I don't know, I guess it really doesn't matter. I'll plug it into the top one. So 2, instead of x, I'm going to put in a 1. And then minus 3y equals 20. 2 times 1 is 2, minus 3y equals 20. Solving for y, subtract the 2, and you get negative 3y is equal to 18. Finally, divide by negative 3, and you get y is equal to negative 6. So your answer to order pair is 1, negative 6. And so, of course, again, we have intersecting lines because we have one solution, consistent and inconsistent. Consistent and independent. All right, so if you have any questions in your homework, feel free to ask.